everybody, today we are going to look at gases and converting volume to moles. Let's get to it. Our goals for today are to first learn a bit about gases and their properties, especially volume, as well as how it relates to moles. We'll then look at something called standard temperature and pressure, and then take some time to practice converting volumes of gases into moles and vice versa. Let's start by reviewing a bit about gases. One of the major properties of gases is that they take on the volume and shape of whatever container they are in. This means that the volume of a gas is inconsistent. It changes based on its surroundings. When a gas expands to fill a container, however, not only its volume changes. The temperature and pressure of a gas are directly related to the number of moles and the volume. And while we'll get deeper into gases in a later unit, it's worth mentioning now that temperature and pressure can affect volume. As such, we have to control some of these variables in order to convert volumes of gases into moles. To measure gases more consistently, and to make it a bit easier to do calculations for gases, scientists have defined a set of standards for temperature and pressure of gases, which is called standard temperature and pressure, or STP. The temperature for standard temperature and pressure is 0 degrees Celsius, or 32 degrees Fahrenheit, and the pressure is 1 atmosphere, or 101.3 kilopascals. Atmosphere is a unit of pressure that is approximately equal to the air pressure felt on Earth at sea level. When a gas is at standard temperature and pressure, it will have a fixed volume. This volume is 22.4 liters per mole, and is the same for all gases, as long as they are at standard temperature and pressure. If a gas is not at STP, new calculations must be applied to get the number of moles of a gas, but we won't worry about that for now. For this unit, assume all gases are at STP unless specified otherwise. The fixed volume of a mole of gas at STP is 22.4 liters per mole, which is a conversion factor that can be used to convert between liters and moles. Let's take a look at some examples. Now, converting volumes of gases to moles is actually a little bit easier than doing mass or molecule calculations, because we're only going to be using one conversion factor. And that conversion factor is going to be 22.4 liters per 1 mole. That's the one we're going to use for all of them. We can flip it so that we can go backwards, but for this first set of examples, we're going to be going from moles to liters. So this first question asks, how many liters of oxygen gas, O2, at STP will be present in 2 moles? So we have 2 moles of oxygen, and we want to get to liters of oxygen. Now, our conversion factor is 22.4 liters per 1 mole. So moles cancel out. We get 2 times 22.4, or 44.8 liters. You'll notice we don't have to do anything different for the fact that this is oxygen gas versus in the next problem where it's nitrogen gas. The type of gas doesn't actually matter. As long as it is a gas and it is at STP, you're always going to be using the same conversion factor. So for this one, how many liters of nitrogen gas at STP will be present in 3.5 moles? We've got 3.5 moles. We want to end up with liters. We're going to use our conversion factor of 22.4 liters per 1 mole. Moles will cancel. 3.5 times 22.4 is 78.4 liters. The last one asks how many liters of ozone, which is O3, at STP will be present in 2 moles. Now, this looks like a little bit of a trick question. You already asked how many liters of oxygen, O2, will be present in 2 moles. This one's O3. But you actually don't have to do anything different. So, with ozone, we've got 2 moles. Our conversion factor is 22.4 liters per 1 mole. And that's going to once again give us 44.8 liters. Now, this might seem a little bit difficult conceptually because you have 1.5 times as many oxygen atoms, but because this gas is ozone, it's still going to end up only taking up the same amount of space. All gases take up 22.4 liters per mole, assuming that they're at standard temperature and pressure, regardless of how many atoms are in those actual individual gas molecules. For the second practice, we'll be using the same conversion factor, 22.4 liters per 1 mole. But this time we're going to be going in reverse. So here we have 11.2 liters of oxygen, 2 liters, and we want to get 2 moles of oxygen. So in this case, we're going to want to do 1 mole per 22.4 liters. The liters are going to cancel. So this 11.2 divided by 22.4, we get 0.5 moles. The last one, 85.12 liters, and we want to get to moles. And you'll notice that on this one, there's not even a gas that's given to you. It just says if you have 85.12 liters of a gas at STP. And that's because really the gas doesn't actually matter at this point. When you're working with gases, as long as they're at standard temperature and pressure, you're always going to have the same thing. So, times 1 mole per 22.4 liters. And when we multiply that out, we get about 3.8 moles. Let's take a quick moment to review. Gases are measured by volume, but the volume is susceptible to change based on the container it is in, the temperature, and the pressure. Standard temperature and pressure, or STP, is a metric used to control these variables. The temperature at STP is 0 degrees Celsius, and the pressure is 1 atmosphere. At STP, there are 22.4 liters in every mole of any gas. 22.4 liters per mole can be used as a conversion factor to convert the volumes of gases into moles or vice versa, as long as the gas remains at STP. When we get into liquids and aqueous substances next week, be careful not to use the 22.4 liters per mole conversion factor, as it only applies to gases. That's it for today's video, and I'll talk to y'all later.